So on page 5, I believe we're on page 5 now. Nope, we were still on page 4. Okay, we're on page 4 of the worksheet. So 50% of Americans are middle class. We're going to conduct an experiment and sample n equals 10 U.S. residents. X is the number of those sampled who are middle class. Do you agree that X is distributed binomially? So we look back at our requirements. First of all, there are two possible outcomes. We can say success for middle class, and we can say failure for not middle class. And the word success and failure is kind of arbitrary. We have 10 repeated trials, and they're independent of one another. So when we randomly grab a U.S. resident, the results we get the first time doesn't impact the results that we get the second time. So those are our 3 requirements. And then we write out our distribution. X is distributed, big B, 10, 5. Sorry, 0.5. 10, 0.5, n, p. Now I'm going to generate the table for the probability distribution. It's not like we have survey results to fill this out with. So you might be like, how do we know what the probability is for each of these? What we do is we get on our calculator, and the calculator provides the probabilities. So the calculator knows the binomial distribution. All we have to tell it is the 10 and the 0.5, and it is able to tell us all of these probabilities. Now the likelihood of sampling 10 people, if 50% of Americans are middle class, I would pretty much expect to get roughly 5 of those people sampled responding that they're middle class. And you will see that the highest probability is for X equals 5. But there's also a chance that we could get 4 or 6 people responding that they are middle class. And then there's a slightly lower value depending on sampling variability. We could get 3 or 7, it wouldn't be unheard of, just a little less likely. But as we go towards 0 or 10, it is pretty unlikely that nobody will report being middle class or that everybody would report being middle class. So this would be all 10 people are middle class. So what we're looking at is the probability that X, the number of people, is 10. And that probability is essentially 0 according to our calculator. So I'm going to show you how to get these numbers. On the TI-8384, go to second distribution. And we scroll down until we get the A and the B. And so what we have is binom PDF and binom CDF. What we want right now is PDF, the probability. Later I'll show you how to use the cumulative density function. But really PDF is all you need. So I'll hit enter. And we're doing 10 trials. The probability of success is 0.5. And so those are the 2 parameters for the distribution. And then what I'm going to do is repeatedly do this to get every single decimal. So the first time I'm going to say put in X equals 0, and it's going to give me 0. Enter, enter, enter. Now that's not 0. What that is 9.77 E-4, which means 0.000977, and so that is approximately 0. People always choke when they see that. That's scientific notation. Another way you might see this is 9.77 times 10 to the negative 4. So that just means super tiny number, basically 0, or very, very close to 0. Now if we go to second distribution again, and sometimes because I'm lazy, I like to go down instead of up. I don't know if it's faster or not. Leave the parameters the same, put in an x value of 1, enter, enter, enter. So I still get a pretty tiny number, but this time I can round it to 0.01, basically 1% chance. And then I go to second, let me see if I can do second entry. And then I can just change this to 2, enter, 0.04. Second entry, this is a little quicker to do this way, 3, 0.12, and so on. 0.21, 0.25, and so on, 0.21, and then it is symmetrical. It goes back down all the way to 10. Now my recollection is that this may not always be perfectly symmetrical. And I wanted to check one other thing real quick. What happens when I don't put anything in for x? Can that still work? So what it does is it gives me all the answers, and I can just scroll along and see all the answers if I don't give it the x value. Another thing I can do is go to mode and go down to float and change it to 2 decimal places. Enter, second quit, second entry, enter, and now it's rounding everything to 2 decimal places for me, so it's a little less cluttered. So that would be a faster way to get all the answers again. But you do need to know, and this is very important and it will continue to happen in the class, that this is a super tiny number that's very, very close to 0. And you do need to understand that 9.77 times 10 to the negative 4th really means 9.77, move that decimal place left 4 times, go back and erase that decimal place, put in zeros in each of these slots. That's the number we are talking about, and you can round that up to 8. So that's what that scientific notation refers to. Don't go thinking it's 9.7. There's no probability that is 9.7. That exceeds the maximum probability of 1. Okay, so that tells you how to generate this probability distribution, because otherwise you would just have no idea. So the calculator helped us, and now that we've got this table filled out, we can go in and answer all of these questions relatively easily. The probability that x is 7 is 0.12. I'm just going to clean this up. Probability that x is 7 is 0.12. There it is. The probability that x is less than or equal to 7 is going to be all of these values added together, 0.95. Or if you want to be clever, you can do binom CDF. Second distribution, binom CDF, 10.57, and it just gives you the answer right away, 0.95. It's like, oh, you mean cumulative, and then it just adds up all the values up to 7. So that's kind of handy, but you always can just use the table. The table is sort of the basic way to do things. 95% of the time, we will get 7 or fewer respondents stating that they are middle class. Now, if I said, what's the probability that we get more than 7? It's going to be 1 minus our previous answer. 1 minus, that should be a minus, 0.95 is equal to 0.05. You could also just add up the p of x values for x equals 8, 9, and 10. So that would certainly be another way to answer that question, and you can see that that is 0.05. Probability that x is greater than or equal to 4. Greater than or equal to 4. So if I wanted to say what is the probability of all of that, I could just add all of those up. Or I could do binom CDF with 3 plugged in, and then do 1 minus that answer, which you might be like, why would you even do that? So yeah, what I prefer is for you to just always make this table and then just add up the values that it's talking about, because I have students get very confused about this. If you understand this, great, go for it. If you find the probability of 3 or fewer, that's going to be exactly the complement to 4 or more. So 1 will be 1 minus the other. So a couple more details. For the binomial probability distribution, x is distributed binomially n comma p. N is the number of trials, p is the probability of success. We didn't really talk about it, but q is the probability of failure. So q is 1 minus p, again it's just 0.5. Mu is equal to n times p. So now, because it's a known distribution, we actually have a formula for mu. You would just take n times p, which would be 10 times 0.5. So mu is equal to 10 times 0.5, which means it's 5. And you're like, yeah, that makes sense. The expected value would be 5 for this probability distribution. And the standard deviation is sigma equals the square root of npq. So let's work that out. Sigma is the square root of 10 times 0.5 times 0.5. So here I go, 10 times 0.5 times 0.5, get 2.5, and then I do the square root of 2.5, I get 1.58. So sigma is equal to 1.58. The standard deviation for this distribution is 1.58. These formulas you might not remember, so they're good to add to your notes sheet.